Guess who's back? Back again. Miss Layman's back. Tell a friend.
Wow. Hey guys, this is Mrs. Lehman from Math with Mrs. Lehman. Welcome back to my YouTube channel. It's been a few weeks since we've really done a video. I've had the privilege of having a student teacher in here, and so I haven't been doing a ton of the primary instruction. So I am back though, and we are going to continue with the videos. So thank you for the nice intro, kids. Shout out to Eminem. All right, here we go. Remember to write down your homework. So we talked about that. It says, what is the ratio of orange words on the word wall to yellow words? So that's pretty hard for you viewers at home to see, but how many orange words compared to yellow words? So what would our first term of our ratio be?
It would be.
You have it written on your, oh, no, you have it written backwards on your paper, but
5.
5 would be orange. So because it said orange to yellow, we need to make sure that this first one that we write, which is 5, on our word wall, comes from. So then we can write a colon. We're going to write this in what we call ratio form. So 5 to, what would our second term be, Mackenzie?
3.
Very good, because we have 3 words on our word wall that are in yellow. So the ratio is 5 to 3. And again, for the people confused on that, orange came first and then yellow. That's ratio format. What's another form that we could have used? Jasmine.
5, 2, 3.
With 2 being the
Word.
very good. So we could say 5, whoops. Helps when you write it in marker versus an eraser. Goes for your homework too. I think some of you guys are confused on that because you've been doing your homework in invisible ink or eraser or something.
And then the fraction 5/3.
Very good. 5 over 3 would be another option. All right, those are all 3 forms of the same exact ratio. All right, convert 6 over 25 or 6/25 to a percent. So 6 over 25, we want to write that as a percent. Who can tell me what I would do next? All right, Jaden.
You would write an equal sign and then a fraction line with 100 on the bottom.
Very good. What do we call that when we have 2 ratios set equal to one another? She just set up a what? Begins with a P. Jasmine?
Proportion.
Oh, nice job. All right, so we have 6 over 25 equals what out of 100? Essentially, we're scaling this number up until we can get it out of 100. Why do we care about it out of 100? Why is that important? Elijah?
Because the most percentage you can have is 100%.
Well, we know percents are out of
100.
100. Yeah, so nice job. So what do I have to do? How many times do I have to scale up 25 to get to 100? William?
4.
Times 4. And to keep it proportionate, to keep it equivalent, we need to do the same thing to the top as well. 6 times 4 is 24. Now, a lot of kids are going to make the mistake of saying this is their answer, 24 100ths, all right? We want to write it as a percent. So what percent is that? Kyle?
24%.
Very nice, all right? So you have to just take it that one step further. 24%. Now, another thing you could do is look at this fraction, 6 over 25, and you could pay attention to that fraction bar, and what operation does that fraction bar mean? What does that indicate? Ethan?
Division.
Very good. So make sure you have your glasses on, kids. It helps with division. All right, so when you take all right, so 6, nothing apparently. I said make sure you have your glasses on. It helps with division. And nobody laughed. That's a story of my life. All right, so 6 divided by 25 equals, and you're going to get a decimal, right? You're going to get, whoops, you're going to get 0.24, all right, 24 hundredths. Now, that's a decimal, right? If we are asked to turn it into a percent, like in this question, how many times do I need to move that decimal place? Always move it how many spots? Oh, come on. Everybody, how many spots?
2.
2. All right, very good. So we're going to move it 2. Now, which direction do we want to move it if we're taking it from a decimal to a percent with a R? Percent. What do you think, Sue Ann? Right or left? Per with an R.
Right.
Right, very good. Correct. Correct, that's right. All right, so 1, 2 spots to the right to make it a percent, and that is 24%. All right, any questions on that? Little Mod 1 throwback. All right, I have a math joke for you kids today. Here we go. Here we go. Number of sheep in Farmer Bob's hop field. This is a bar graph.
I get it.
Okay. Do I need to explain that to anyone?
No.
I do need to explain it?
No.
Sheep say ba. Anyway, so it's just a joke. Yes. I don't know if our viewers could hear that, so Jan, I'm gonna let you say that into the mic.
That's a bad joke.
Oh man, kids.
We're killing the crowd.
All right, this is when everybody shuts the video off. All right, I'm done. Okay. All right, so your homework yesterday was about these number lines. So the key thing is you had to identify what the scale was. Now, kids, 34. Kids are mixing up the fact that what something is labeled isn't necessarily what each jump is worth. All right, so for example, people look at this first one and say, oh, it's using a scale of 1, right? In actuality, what are they jumping by each time? What are they jumping by each time in example 1? Timothy? Half. Very good. So even though they only chose to label every other one because it would look like a chaotic mess on their number line, they are really only jumping by half. So this is the number 4 and 0. Hopefully you could identify that. If not, please come see me for extra help. So 4 and 0. Who can give me a scenario that would deal with a positive 4 and a 0? Liz.
My house is 4 miles away from school.
All right, so what would 0 be?
The school.
I guess. Technically, though, it could have been the other way around, right? So yeah, they're 4 apart, just like 0 and 4 are 4 apart on the number line. Very good. Let's move on to the next one. Number 2. Everyone look in your book and identify the scale. It is labeled by 100ths, but what is each jump worth? What is each jump worth? Mackenzie.
1.
Each jump is worth 1? Yeah. You got sucked into the math layer, or the math wizard's layer there. Look at, these are only labeling 100, but there's a jump in between. So that's what you have to be careful of. So what is it really counting by, Mackenzie?
Half?
Not halves. Halves of 100, which is, everybody?
50.
50, yeah. So it's counting by 50s, all right? So this jump right here is 50, then it's 100, 150 to 200. So what is between 150 and 200? What's between 150 and 200? Mackenzie? Very good. Nice job. All right, so 175 is this dot that I'm going to color red. All right, that's 175. And then negative 200, I just gave you the answer, is our other one. All right, so who can give me a fun story for that? Somebody else.
I don't really
Or a not fun story. Just a story that involves the numbers 175, and negative 200. Jaden.
A miner dug 200 meters below the surface to build an elevator. The top floor of this elevator would be 175 meters above the surface.
Wow, so he's not only coming out of the ground, he's going way up there. All right, nice job, Jaden. All right, good. So she dealt with something below ground and then something above ground. All right, the next one, please hold. Oops. Okay, so the next one, what is the scale that they're counting by here? Again, they label every one, but that's not what their scale is. Well, what is it?
It's by halves.
Very good. So the first number, the number here with the blue point is what? Everybody? Negative 1/2, and then this one in green is negative 1 1/2. Very good. Okay, so who can give me a really quick story about negative 1/2 and negative 1 1/2? Willow.
Aisle 1 is negative 1/2 away from 0, and 0 represents entrance. And aisle 2 is 1/2 away from 0.
Okay. Good.
I walked negative 1/2 west to my mailbox, then went negative 1 1/2 west to my cousin's house.
Okay, very good. So I gave the example earlier that I was Christmas shopping for my dear husband, and I didn't know what to get him, and I had no money, so I borrowed 50 cents, half a dollar from my mother to get him a nice toy out of the coin machines outside of Walmart. So that means that I owe my mom, I am short to $1/2, right? And I didn't like the gold fake ring that I got him, so I tried my luck 2 more times, costing me an additional $1, right? So now I have 3 prizes for him for Christmas, and I also owe my mother $1.50. So, Merry Christmas.
Merry Christmas.
It's not about presents, kids. All right. Anyway, what is the scale for 4? What is the scale for question 4? What are they counting by? Kyle.
They're counting by ones.
Very good. And then question 5, what are they counting by? What are the skips? Or what are the jumps? Elijah?
By twos.
Very good. All right. So we're going to move on. I think you get the gist. All right. So when you have a negative number, you should be using words that represent a loss. All right. So a charge, a debit, below sea level, any sort of decline or decrease. Do I dare call on you right now, Ethan? Go ahead, Ethan.
Your battery for your phone drains 5%.
Oh, wow, that's a good one. Yeah, so you have a draining battery.
That's always good.
What would we do? All right. Okay, so today we're going to do a little bit of a review from approximately 1st grade. We're gonna tack on some fancy vocabulary for you, and it's going to turn into 6th grade. Okay, so do you guys remember when you were wee little 1st graders, maybe 2nd? I'm not quite sure anymore because everything kind of shifted around, but it's probably like pre-K now. Do you guys remember learning, okay, the teacher would say 1 compared to 2. Which one is bigger? You guys remember that?
Yeah.
And then she would say 1 is less than 2. This is why I don't teach primary, right? So 1 is less than 2, and they'd say the number monster eats the bigger number, the number alligator. So when you see the number monster bust out in a math problem, it's not going to be called the number alligator or the number monster, all right? It's going to be called inequality, all right? So inequality means you're not going to see an equal sign. You are now going to see greater than or less than, all right? So the other big change in middle school is we're no longer going to use the teeth. All right? So there you go. When you get to college, they tend not to take kindly on that, so we need to get in the habit of maybe erasing those if you feel like you still need them. All right? So, inequality statements are just comparing two numbers, saying that one is bigger than the other one. So, I'm here to tell you about the scary place called the math world. And in the math world, there is a number monster. And the number monster enjoys eating the greatest numbers. All right? And what does it do? It points at the little guys. It's a very cruel thing. This number monster is a little bit, sick in its ways, but it has a method. It will come into any math problem, and it will order the numbers, either least to greatest, greatest to least. And then it's going to eat the biggest numbers, and it's going to point at the little numbers. And that's what he does. All right? I'm sorry I had to ruin that for you kids. It's not a friendly number alligator. It's actually a monster, and it's very methodical in its approach to this. So anyway, let's give some examples of how this works. All right, so it says the amount of money I have in my pocket is less than $5, but greater than $4. So less than 5, greater than 4. What could a possible value be for the amount of cashola I have in my pocket? Timothy, how much money could I possibly have?
1.5.
Everyone today has said that. $4.50. So that's valid. All right. Could we have picked some other numbers? Yeah, we could have picked
4.75 cents.
Yeah, we could have picked anything. All right. So as long as it's less than 5, so it can't be 5, and it's greater than 4, so it can't be 4, but it does have to be in the middle. All right, so write an inequality statement comparing the possible values. So again, inequality means it's going to have the number monster involved. Of the value of the money in my pocket, we're going to compare that to $4. So how much money do I supposedly have in my pocket? $4.50, and we're comparing that to $4. So the number monster has lined them up. In this case, greatest to least, right?
Yep.
Which number is it going to have its mouth open to? Drooling out the side. Jasmine?
$4.50.
Very good. So again, we're going to leave the teeth out. The number monster is old now and it lost its teeth. All right, so $4.50 is greater than $4. That's how you would read that. $4.50 is greater than $4. Now we need to write write an inequality statement comparing the possible value of the money in my pocket to $5. So the money in my pocket is $4.50. I need to compare that to $5. So on your paper, go ahead and write that. I'm going to pause the video while I check. All right, so as we read this left to right, it should say $4.50 is, everybody?
Less than.
Very good. $5. So $4.50 is less than $5. Okay, so that's just an example with two quantities. You can have more than that, but the examples today just involve the two. So we are going to now look at this number line that they gave us on page 36. And we have 10 jumps in that number line. And we are in charge of plotting the three numbers we just talked about. $4, $4.50, and $5. Can anyone come up with a good scale? Now, I see some people slapping 0 on their number line. No, we don't need 0 in this scenario. So what could we start with? What's our lowest value that we need? Yes. 4. Very good. So we could start with 4, and we want to get up to 5. So if we have 10 jumps, how much would each jump be worth? Liz?
2.
So you want to say $4, $6, $8, $10? We don't need all that, right? We just need between 4 and 5.
25 cents.
We could still spread out more, because if we counted by $1, it'd be $4, $5, right? That'd be too small. If we did $4.25, it'd be $4, $4.50, $5. We're essentially wasting all this extra space down here, right? So we want to spread out even further. So what's a smaller increment than a quarter?
By cents.
Very good, William. 10 cents would be perfect. So let's label this one 4. Now, do I have to label every line? No, but that still does not change that each line, or each jump, I should say, is worth 10 cents. So here's 10 cents, 20 cents, 30 cents, 40 cents. Here would be $4.50, $4.60, $4.70, $4.80, $4.90, and $5. Does that make sense to everyone? Are we good there? I kind of say it's like moving into a house and just keeping everything in the corner and never spreading your stuff out, right? It's like putting frosting on a cake and you just lump it on one side and you never spread it to the other side. You want to make it nice and even across, right? You also don't want to spread it too thin and then have it all over the table, like that does you no good. So 10 cents is a nice jump. So let's plot our points there right at the intersections of these lines. So now we are going to write an inequality statement that involves these three numbers. So if you're the number monster, you're going to line them up in order. Let's line them up least to greatest first. What's our lowest number? Everybody? $4. $4. What's our next number? $4.50 and $5. All right, so I left a space in between to write my inequality symbols. So 4 compared to 450. 4 is less than. 4 is less than 450. 450 is less than 5. Very good. So what do we notice about the arrows? What do we notice about those? Jaden? I'm going to have you say that into the microphone.
They're pointing the same direction.
Very good, yeah. You are not doing it correctly if you were to do something like this. I'm going to write this in red, and I'm going to immediately erase it. So if we did this, this is incorrect. You do not want to say 4 is less than 5. 5 is, that's weird, okay? Put them in order, okay? Least to greatest. They least to greatest or greatest to least. Now, if we wanted to switch it greatest to least, we would just reverse the numbers. 5, 450, and 4. And 5 is what compared to 450? Greater than. 450 is greater than. Very good. All right. Any questions on that? That's how you write inequalities involving three numbers. So really the only difference between when you were a little kid learning this is you don't put the teeth on there anymore, okay? And you have potentially three numbers you have to deal with. Soon we'll start throwing in some algebraic terms as well. But for right now, that's what it looks like, all right? So let's look at this next example, which is about shoe sizes. We have three shoe sizes here, 10.5, 8, and 9. So least to greatest. Least to greatest. Who can give me the smallest shoe size? Everyone just shout it out. What's the lowest? Smallest shoe?
8.
8. And then leave a space. What would be next?
9.
9 and
10.5.
10.5. This is really not difficult, right? All right, so 8 compared to 9. Less than. 8 is less than 9, and 9 is less than 10.5. Very good. So you would read that 8 is less than 9, which is less than 10.5. Now we're going to do greatest to least. So what's my first number? 10.5. Good. Leave a space. Middle number stays the same, and then 8. All right, so 10.5 is greater than 9, which is greater than 8. How are we feeling about this? All right, I'm going to pause the video and chat with the kids for a second. All right, we are actually on page 39, and we're going to take a look at this little chart here. We have three numbers listed, -1/4, -1, and 0. And we need to put them in order so that they fit in these boxes. So we want something is less than something is less than something. And you read these left to right, just like you would a word or a sentence. So we are going to look for, we're going to put these in order. What do we want? The greatest number or the lowest number here in the red box? I'm hearing a lot of kids saying it, but I doubt they can hear you. Lowest. Very good. What is our lowest number here? Careful. Be careful.
-1.
Very good, Julius. -1 is our lowest number. So -1 is for this left on the number line. And then what would our next number be? Everyone? -1/4. -1/4. And our largest number is 0. So if we did this correctly, this should make sense. -1 is less than -1/4 is less, which is less than 0. Does that make sense? Pretty good. They're in order from least to greatest. So let's look at our next example. Now they switched the order. They have instead of less than, they changed the inequality to greater than. So something is greater than something, which is greater than something else. So what should go in the blue box right here? What number? 0. Very good. So 0 is greater than what middle number should it be? -1/4. And then our smallest number, everyone, is
-1.
very good. All right. So the whole point of this is so that you understand that you have to order them least to greatest or greatest to least. And if you change that, it's obviously going to switch the order of the numbers. All right. Your homework tonight is going to be this problem set. We're going to skip the middle of it, so you do not have to do 7 through 11. Please don't exit off, because we will probably come back to that at some point. But we are going to do 1 through 6 for homework, and you are going to do 12 through 15. And we're going to run through a few examples right now. Okay, so you need to read each problem, and then you're going to write it as an inequality statement with the number monster in there. 7 feet below sea level. What integer is that talking about? 7 feet below sea level. What number is that, Jasmine?
-7.
Well, -7. And that's farther below sea level than 4.5 feet below sea level. What rational number should we write there? What number is that? 4.5 feet below sea level.
-4.5.
Very good. -4.5. All right. So let's put these down here. -7 compared to -4.5. So we need to decide, is -7 less than or greater than -4.5? What do you think, Will?
-7 is less than 4.5.
Very good. -4.5. Yeah. So there you go. -7 is less than -4.5. Again, it points at the little guy. It goes to the bigger number with the mouth open toward that. And you read it left to right. So you'd read that. Well, who can read that for me? Who can read that properly? Willow, you want to venture a try? Oh, no, just read the statement.
Okay. 7 feet below 0 is...
Oh, read just inequality, I should say. Sorry.
-7 is less than -4.5.
Very good. Beautiful. Beautifully said. All right. 16 degrees Celsius is warmer than 0 degrees Celsius. So keyword 16 degrees, and that's warmer than 0 degrees. So we have 16, we have 0. What inequality should we write in between there? So we'd say 16 is what than 0? Kenzie?
Greater than?
Very good. 16 degrees is greater than 0 degrees. Both sound just lovely. All right, let's go down to the bottom here. So your job is to finish that top part and then finish this bottom part. Let's do the first one here together, number 12. It says 3 integers between -4 and 0. So integers means what? Who can tell me what an integer is? Jaden?
A whole number on either side of the number line.
Very good. It's a whole number. So we need a whole number. I'm going to write that here. A whole number between -4 and 0. So what are our options there? They're pretty limited. What are 3 integers between 0 and -4?
-1, -2, -3.
Beautiful. Yep. -1, -2, -3 are our only options. So we want less less than. So when it's a less than symbol, we want to go least to greatest. So what's the smallest number here? Smallest value? -1, -2, or -3, everybody?
-3.
Some people got tricked. It's -3, right? -3 is further left on the number line. So -3, what would be in the middle? -2 and -1, right? So -3 is less than -2 is less than -1. You are going to see, whoops, wow, it's jumping all over the place. Oh, all right. Sorry for any potential seizures you may have had. Rational numbers. What does rational number mean? It's not a whole number. It's not an integer. So what must it be? Liz?
Any number that can be turned into a fraction.
Yep. So it could be a decimal or a fraction. Okay? So obviously there are no integers between 15 and 16. There are only rational decimals and fractions, right? So it's your job to pick those. Everybody could have different numbers, all right? There's an infinite amount in between there. So there's an infinite amount of options. And then same for 14, and then 15 is asking for integers again. All right, any questions? All right, thank you for watching Math with Mrs. Lehman. Have a great day.